Good morning, Pre-Calc. So today we are going to be starting a brand new chapter. We're going to start chapter 6. We're going to start with something called the law of sines today. So basically our goal for the day would be able to use law of sines to solve trig functions. So we're going to start up with a warm-up. And I guess typically when we were actually in class, I would ask you guys, hey, what are some types of triangles? But since you guys are not here to answer my questions, I'm just going to give you guys the biggest holistic list I can of the triangles that I know. All right, so some triangles that I know. I don't want to write that big. That'd be crazy. All right, so here are some triangles that I know. First one that comes to mind is a right triangle. So a right triangle is going to be a triangle that has a 90-degree angle. I also know about acute triangles, so that means that they have one angle that's going to be less than 90 degrees. I also know about obtuse, which is an angle that is going to be greater than 90 degrees. Some other things I might know, I probably know equilateral, so equilateral. I know equilateral, hopefully I spelled that right. I'm trying to think of any others. I guess there's like the classic, like the 30, 60, 90. I also know probably the 45, 45, 90. That's a classic. I'm trying to think of any others that I know. Maybe an isosceles. An isosceles right triangle is a good one. So for the most part, all of these triangles are going to be right triangles. Most of them are going to be right triangles, except maybe for the case of the acute and the obtuse. So really, most of the triangles that we have dealt with our entire geometry career have been right triangles. So what law of sines opens us up to do is how in the world can we work with triangles that are not right? So if I gave you a triangle that looked something like this, which I know that's not the straightest thing in the world, we'd say that this is probably an obtuse triangle, but that's really all I could say about it. I really couldn't tell you very much about it because everything that we have learned so far, all of trig that we have learned so far, has dealt with right triangles. So today we're going to talk about, hey, what happens if I have something that's not right? So we're going to start with this. The law of sines. If triangle ABC has sides A, B, and C, then we're going to have the following. So I'm going to draw two different options. Say I have an acute triangle and it looks like this. We can say that this is angle A here. We could say that this is angle B here and this is angle C here, and this is not going to be right. So let me make this look a little bit different so we know for sure, hey, this is not a right triangle. There we go. All right, so we can say that this here is C, this is B, and this is side A. Notice how like capital angle A corresponds to its side that's directly across from it, lowercase a. And let me draw one that's obtuse too. So I'm going to draw one that is obtuse. Let's see, we'll have A here, B here, C here, which means this is lowercase b, lowercase a, lowercase c. So this is triangle ABC. So it could be acute, it could be obtuse, it could really be anything. Let's go ahead and write the law of sines. The law of sines says this: side A divided by the sine of angle A is equal to side B divided by the sine of angle B is equal to side C all over the sine of angle C. That is the law of sines here. So we could also write, and this is the exact same thing, we could say that the sine of angle A all over side A is equal to the sine of angle B all over side B, which is equal to the sine of angle C all over side C. This is the law of sines, and we are going to be using this for the next pretty long amount of time. All right, let's go ahead. In fact, I'm going to kind of copy and paste this so that we can kind of keep this on our record. We're going to use this in a little bit. So let me actually make the screen a little bit bigger. And we're going to go on to our very first problem for the day. So our very first problem for the day is this. We're going to say that angle C, so we're going to say that angle C, could I please write, please? There we go. All All right, so we're going to say that my angle C is equal to 102 degrees. We're going to say that my angle B is equal to 29 degrees, and we'll also say that side B is equal to 28. So what I want to do is I want to solve for the entire triangle. We're pretty much going to be, this is going to be the bread and butter of what we do for the next couple of weeks. So the first thing we're going to do, I'm just going to draw a triangle. So it doesn't really matter which triangle looks like, but it looks like it's going to be obtuse because 102 is bigger than 90. Doesn't really matter though. So we'll say that this is 102 here. I'm just eyeballing. You can kind of put it wherever you want, but we'll say B is 29 here, which would make this angle A. I know that side B, so side B is the side that's directly across from angle B. So this is 28, and this is all the information I know. I want to find every other piece of information. Well, the easiest thing I could do first is solve for angle A. Angle A is going to be really easy to solve for because I know that angle B, so 29, plus 102, plus A, they all have to add up to 180 degrees. That's just kind of how it has to be. So if I get 131 plus A is equal to 180 degrees, and we subtract 131. We're going to get 5, 4. There we go. Okay, so we should get like 49 here. All right, so angle A is going to equal 49 degrees. So we've kind of figured out probably the easiest part of this whole question, which is angle A, but I need to find out all the other pieces of information. I want to know what is side A's measure and what is side C's measure. And that's where the law of sines are going to come in handy. So I'm going to go ahead and copy and paste the law of sines in here, and we're going to use this to find the rest of my values. So the first thing that I know, in fact, the most important thing I probably know is an angle with a corresponding side. So if I can find an angle that has a corresponding side, that's going to be my most important piece of information. That happens right here at B. I know angle B is 29, and I know that side B is 28. So in my law of sines, I know that side B is 28, side B is 28, and I know that the angle of sine B is going to be 29 degrees. So that's pretty important. I know that that is going to equal A all over sine of A, and it's going to equal C all over sine of C. Okay, well, I know some of these things. I know what sine of A is. I know that, you know what? Actually, sorry, guys, I misspoke here. That's my bad. Sine of 29 degrees, my bad. All right, so we're going to use our calculators here a little bit to solve this, but let's go ahead and fill in anything else I know. I also know the sine of A. The sine, angle A is 49, so I'm going to replace A with 49. Replace that with 49. And I also know that angle C is 102. So angle C is 102. So those are really all the things that I know. So what I'm going to do is I'm going to focus on this first equation here. I know that 28 all over whatever the sine of 29 is equal to A over sine of 49. So I could solve this algebraically. I'm going to solve it algebraically first, and then I'll talk about calculator in a minute. So if I have A all over sine of 49, if I want to get 49 out of the denominator, I'm going to multiply by sine of 49. Multiply by sine of 49. And so I get sine of 49 times 28 all over the sine of 29 is equal to A. So if I evaluate this on my calculator, which I'm going to do, I don't know if you guys can see this. I don't think you can see this on your screen. So I'm actually just going to pause and I'll get a decimal approximation. Okay, after evaluating this on my calculator, making sure I am in degree mode, I got 43.588. And that's going to be the measure of side A. Now, to find the measure of side B, not side B, we already have that one. To find the measure of side C, it's going to be the same process. I'm going to set the same thing equal, and we're going to solve. So the next one I'm going to do, and I'll do this in a different color here, I want to solve for this equation here. So I have 28 all over the sine of 29 is equal to C all over sine of 102. If I multiply by sine of 102 on both sides, I'm going to get sine of 102 times 28 all over the sine of 29. And I'm going to go and pause and evaluate that. All right, so what I got here is that C is going to equal 56.429. 0.492. And I also realized here, I think I might have done, oh, no, I think we're okay. Just making sure I didn't. All right, so those are going to be my values here. We're going to have side A, side B, and angle A are the things that I solve for. So I'm going to go and highlight those. But just be aware that these are the type of problems that you're going to be solving for the next couple of weeks. So these right here are our solutions. All right, so I'm really just going to do one example problem today. We'll get to others when we start going back in person, but this is really what I wanted you to see today. And that is it.